Every era has a piece of technology that, well, sort of slips through the cracks of memory. Not because it failed, but because it worked so well it just blended into the background. During World War II, armies all over the world built bunkers, field stations, listening posts, and supply depots in environments that swung between brutal cold and blistering heat. They couldn't rely on fiberglass, spray foam, or reflective barriers. They didn't have modern house-wrap membranes or plastic vapor barriers. What they had was something older, simpler, and honestly, shockingly effective. A wall insulator so durable that many wartime shelters using it survived decades of abandonment without collapsing, and, well, many still maintain stable interior temperatures today. This wasn't nostalgia or clever marketing. The material worked because it was engineered for war, conditions where insulation wasn't about comfort but survival. Whether soldiers were stationed in alpine fortifications, submarine pens, or wooden barracks in the Arctic convoy routes, this forgotten layer kept structures warm, dry, and, surprisingly, quiet. And the lessons from it are something modern builders, homesteaders, and off-grid experimenters can apply right now. So, let's dig into what this insulator actually was, how it functioned, why it beat many modern options, and, well, how you can replicate it with simple, durable materials. The World War II wall insulator worked because armies needed a material that could handle extreme conditions without failing. The core material used by many Allied and Axis forces was a dense combination of mineral wool or wood fibre board paired with kraft or tar paper. It wasn't glamorous, but it was brilliantly engineered. Mineral wool, in particular, made from molten rock spun into fibres, created an insulation that resisted moisture, pests, temperature swings, and fire. During World War II, it wasn't used because it was cheap. It was used because it was almost indestructible. Field engineers needed something that could be pressed between wooden studs packed into concrete bunker walls or layered inside metal structures without losing its insulating value. Mineral wool fit the task perfectly. Even when soaked, it retained thermal performance far better than organic materials. When exposed to fire, it charred instead of burning. And when compressed, it maintained structural integrity. That reliability allowed troops to build insulated bunkers and barracks that could keep out winter cold in Norway, heat in North Africa, and, humidity in the Pacific. You can still find wartime structures in Europe where the mineral wool insulation has survived in near-perfect condition. Modern fiberglass, by contrast, sags, deteriorates, or, well, loses its loft over time. The World War II choice was deliberate and based on performance, not price. The strength of the system came from layering materials instead of relying on one single insulator. The insulation was only one part of the system. The real brilliance was in the combination. Engineers layered mineral wool between wooden panels, then covered it with tar paper or kraft paper as an early vapor barrier. This prevented moisture from penetrating deeper into the structure and kept the wool dry enough to function even in freezing temperatures. The layering also created a sound barrier. Bunkers insulated with this combination were quieter, more stable and more temperature-resistant than many modern sheds built with a single thin sheet of foam. Soldiers working in communication stations or ammunition depots appreciated the improved acoustics long before civilian builders discovered the same benefit. For today's survivalists or off-grid cabin builders, the lesson is clear. Insulation is not about one miracle material. It's about combining density, moisture control, and structural support. That's why many World War II buildings still stand strong. Modern insulation materials, particularly fiberglass rolls and low-density foam, often degrade. So, fiberglass breaks down with moisture. And, well, foam can warp, crumble, or even attract insects. The World War II solution was rooted in materials that don't rot, don't harbour pests easily, and don't dissolve under temperature changes. Mineral wool performs consistently regardless of age. You see, it resists mould because it doesn't absorb water the same way organic materials do. The wood fibre board used in temporary structures, when sealed with tar paper, lasted remarkably long because the tar layer prevented rot and insects from taking hold. In field tests today, mineral wool still outperforms fiberglass in both R-value stability and durability under compression. That makes this old material far more modern than it looks. The World War II approach provides practical lessons anyone can apply in small cabins, sheds, or off-grid shelters. If you want to replicate this wartime insulation method, you don't need original materials. You can build a highly effective, extremely durable wall system using mineral wool batts paired with heavy craft paper, builder's felt, or asphalt-saturated sheets. The process is, well, quite straightforward. First, you want to pack the mineral wool tightly between the studs or framing members. It should fit snugly, you know, without leaving any air gaps. Next, just apply a layer of heavy paper or felt over the entire wall section. Make sure to staple it firmly so it acts as a wind and moisture barrier. Finally, board over the interior with plywood or wood planking. This will compress the wool just a bit and protect it from damage. This creates a dense layered wall that, in a way, mimics wartime strength while still meeting modern needs. It performs exceptionally well in semi-heated structures, small off-grid cabins, and sheds that are exposed to wide temperature swings. The absence of fragile plastic layers means the wall can breathe, which helps prevent mould issues that often develop in sealed synthetic systems. Another practical application is using mineral wool in earthen or hybrid shelters. You dig a partial earth berm, line the interior with wooden panels, fill cavities with mineral wool, and then seal it all up with craft or felt layers. The result is a shelter that, honestly, remains stable, warm, and moisture-resistant, even in some of the harshest climates. The wartime solution, you see, really proved its worth because it was built for survival, not for convenience. Engineers didn't choose mineral wool and layered paper because they were trendy or fashionable. No, they chose them because buildings absolutely had to function during bombardment, temperature extremes, and, of course, constant human occupation. You see, a comfortable barracks was more than just comfort. It was readiness. A warm bunker meant alert soldiers, ready for anything. And, well, a quiet communication post meant effective work. Quite essential, wouldn't you agree? Now, these structures weren't designed to make a contractor money. No, they were designed to keep people alive. That's the true purpose here, if you think about it. The fact that many of these insulated structures still stand, still shelter equipment, and still maintain stable interior climates is, honestly, a reminder that durability and thoughtful layering outperform flashy materials every time. If you enjoyed this deep dive, well, make sure to subscribe and share. For viewers who appreciate history that teaches real survival lessons, you know, forgotten World War II wall insulation is a perfect example of how older technology still outperforms newer materials. If you want more research-based guides, more practical historical knowledge, and of course more forgotten wartime engineering breakthroughs, subscribe to In the Beginning, share this video with fellow enthusiasts, and stay tuned for the next deep dive.